Alright, so here's a question from the June 2019 paper, question number 19. We're right near the end of the paper now, and what we have here is a triangular prism. You've got an angle, a couple of sides, and then you're also given a ratio. If you look at the ratio down here, d to m and m to a, so that is, it wants you to put the m along this line, d to m and m to a, and it's 2/3 where m is, sorry, 2/5 I should say, because it's 5 parts. If one part's of 2, the other part's 3, it's actually 2/5. So this will be the m here, and that would be 2/5 of the way along there. Then along the way here, 3/5 of the way to get from m to a. Okay, so that is finding our point m. It's obviously something we need to do. It already gives you 15 along the bottom. It's 15 here and the 35 here, and we want the size of the angle between EM and the base of the prism. Alright, so we want something. I'm just gonna, first of all, I'm gonna just slice this because we don't care about the bits that happen past M. So kind of just slice that here. That's kind of a cutting that bit away. And that's a plane. So I'm going to just cut it and just get it kind of away. Kind of try and imagine this. Not very easy to imagine actually, but this is going to be a 3-dimensional trigonometry. Okay, so we want the angle from this point M up to E. So it looks a bit like that. Actually gonna keep having a look at that. I'm just going to use the ruler to do that a little bit neater. So M is here roughly, and I'm going to just draw the angle to E to M. And so if you see what looks like here, I mean, you'll have a ruler, make sure you use it, because if you did it like me and was a bit scruffy with it, it might get you a bit more lost. You're more likely to understand where you're looking at. So I'm not going to draw the other plane actually, I'm just going to leave it like that. So the angle we want is here, because it's got, this is M, it says E to M. So E to M is E to M, and we want this angle, so because it says the base of the prism, which is here, base of the prism, and E. Okay, hopefully we can all see that. So that's the angle we want. Now, I think there's quite a bit to do before we could do that. So this is a right angle triangle here. And we don't know anything about it at the moment. We don't know the length of this, we don't know the length of that, we don't know the length of that, or any of the angles. So we need help with that. Now this is a key here. You can see the end of the prism is this part here. The end of the prism, it gives you some information. It tells you that it's 15 going backwards. That angle's 35. And if you think about what it shares with the other triangle, it shares the height, that EB height. And you can take different colours into, like highlighters and stuff, into an exam. Make sure you do that so you can sort of see. This E to B is the same height whether you're looking at this right angle triangle or this right angle triangle. So if we find this height, and we can do that using this 35 and this 15 and trigonometry. So for this angle 35, we need the opposite side and we have the adjacent. So the ratio we want, if we think of SOHCAHTOA, that's something you have to, if you're going to touch on any right angle triangles, you need that SOHCAHTOA. Okay, O and A, it would be the TOA, which is the tan ratio. Okay, so tan Remember that the angle always goes with the ratio. Equals opposite, we don't know the opposite, divided by the adjacent, which is 15. Okay, I'm just going to put this equal so we can see it across this way. So if I get my calculator, now on this you have to put the number first. So actually, to get this in a better format, sorry, it would be tan. I kind of do this automatically, but I'll show you 35 because you're timesing both sides by 15. And that will get you your opposite sign. So you're going to do that in your calculator now. So that tan 35, and I have to do the 35 first, but on a normal Casio calculator, you should do it, and then it opens a bracket, and then it looks a bit like this. Make sure you close that bracket, and then times 15. Okay, so that gives me my height, which equals 10.503. So that's this 10.503. All right, centimetres. That helps us because now we've got the height, and so we just need. So we've got the height of this one. We need this one here, or this one here. Now, think about what you can get. Well, if you look at this one along the bottom of my red triangle, that's actually the hypotenuse to this triangle here. I'm going to get another colour. I'm just trying to show you visually, really. It's difficult on papers like this sometimes. So this here, although it's at an angle, it is actually a right angle triangle. All prisms have lots of right angles. So this yellow one here is another one. It's like a right angle which is laying down flat on the floor. And your right angle is in this kind of corner here. So now, so this is going to be, we've got two side lengths. We've got 15 and 15 there. Now it's not actually 15 because 15 is all the way along, and we know that this part here is just 3/5 of that. Remember, we broke it down. It's another level of difficulty. They've got this breakdown here. So 3/5 of 15 would be 9. So actually that would be 9 centimetres by 15. So if we're using this time Pythagoras, so a squared plus b squared equals c squared. So when it's all about lengths, we can use Pythagoras. So 9 squared plus 15 squared equals c squared. We're after c squared. We are after the longest side. And then again on the calculator, 15 squared plus 9 squared, 306. 306 equals c squared. Therefore, the square root of 306 is c. Square root button. Where is my square root button? It's not. I'm missing it somewhere. Oh, it doesn't seem to have any square root button. That's a bit silly. I'll do it on my calculator here. It's a square root 306 is 17.49. Sorry, I couldn't show you that. I just had to use my calculator. Is C 17.49. So that's this length here. So now, if you look back at your whole thing, your red triangle, we've got the base, we've got this line here, we've got the height, we have got hypotenuse, but because we want an angle, we actually only need 2 side lengths. It doesn't matter which 2, but we've got 2 now. We've got the base and we've got the height. So we can use trigonometry again. And if you think relative to this angle here, we've got the adjacent and the opposite again. So we're looking also at tan. This time you need to do it as a angle find. So tan theta equals the opposite, which is 10.503, divide 17.49. So what you can do that first and then do tan to the -1, or you can do it all in one step, which I normally do. We write tan to the -1. It's the inverse of tan basically. So when you take it over the equal sign there, it becomes the inverse. And let's see if I can do that on this calculator. So, I probably needed that second. Anyway, so tan to the -1. I'm not sure if it's going to let me. No. Okay, I'll do this bit first. 10.503 divided by 17.49. There is a little bit of rounding going on there, but they normally allow a little bit of rounding. Equals that, and then I'll press tan to the -1, and that gives me a number of 30.98585, and that's in degrees, because we are looking for this angle here. And now that is our answer. Now you need to look back, okay, what does it want format-wise? 1 decimal place. So if I do this to 1 decimal place, it actually becomes 31.0, because you obviously can't round 9 up. It just becomes 10. Okay, so I hope that's quite clear. There's quite a lot going on in that question. Remember, never give up with the whole question. Just start, see what you come up with. Even just selecting this m value and finding this 9 across here, you never know what's going to get you the points. That in this case would get you a mark, just finding this 9. And then you might spot that there's a here, and then that's not trigonometry, that's Pythagoras. So getting these bits done and having some understanding of trigonometry, because I've not used any sine or cosine rule. I've just used the basic trig, if you like, SOHCAHTOA and Pythagoras. Okay, so it is just understanding what you need to use. And if it's a 3D image, it's very likely it's going to be some form of at least Pythagoras twice, or a mixture of both trigonometry and Pythagoras. I mean, you've got angles involved, so it can't just be Pythagoras. But if sometimes they are just lengths, and you are just after the distance here. So you never know. Just have a read through it and have a go at even doing part of it, and you never know what marks you're going to pick up. But that is the whole question. Hopefully that was clear. Please feel free to comment down below if you have any questions. Thank you.